All right, everyone. Welcome to the Aerospace and Defense Showcase. We're really excited to have you all, and we're excited to get going. Today's sessions are going to be two sessions. Each session is going to be about an hour plus, plus 10 minutes, minus 10 minutes here and there. Right now, we're doing the opening remarks and presentation. After that, session one, and then session two. The vision of Deep Tech Showcase, for those who are new or are joining for the first time, is to bring deep tech to market. So there's a lot of really great ideas out there that don't end up being used or utilized in the way that they could or should be. So our goal is essentially to help companies that are developing dual use, interesting technologies and find the right home for that technology or the right partnerships or the right investor. So within that, we created an ecosystem consisting of startups, tech scouts, and investors. The tech scouts could be from corporations or government and government. Anchoring all that are our events. We have one event a month, barring December. This December, we did not have an event. We have once a month. This month, as you are already aware, is Aerospace and Defense. Coming up, we have some really interesting stuff, especially in the AI field. We'll talk about that on a future slide. Essentially, this is a way for people to get in front of each other. And as we spoke about earlier on this call, there's a lot of geographic diversity. So we're really happy we're able to use this forum to really connect the United States. In addition to that, we help with guided introductions. So if you tell us on this, if you tell us by email or even on this call, hey, I'm looking for companies doing XYZ, or if you're a company and you're looking for more traction, we're always happy to talk about that and see, where we could be a matchmaker and help facilitate, finding the right people in the right places. So as earlier discussed, the IoT Cyber and AI Showcase is going to be in February, which is very relevant considering the news. I'm sure everyone has been watching and looking. And then we're going to have an Energy and Clean Tech Showcase in March. And with that, I hope you have joined us. Yoav, feel free to jump in.
So, hi everyone. I'm Yoav Joe Sadan from Eagle Point Funding, and we're kind of the parent of Deep Tech Showcase. And our job is to help companies get non-dilutive funding, R&D funding, SBIRs, broad agency announcements. Clearly, I'm the least interesting person on this showcase today, so I'm going to make it very quick, and I'm going to set the stage for either panelists or the companies and people to discuss. As some of the people heard, the administration has done a pause on the grants, and then right after, so rest assured, both the release from the courts and the Pentagon, SBIR's Small Business Innovation Research is not considered a grant. It's a type of contract and that the Department of Defense is heavily relying on. So we first do an assessment with every company that's interested in trying to figure out what they can win and how do you navigate these interesting, let's say, territory right now. So our job is to understand what you want to do as a company, then see the programs that are there. We'll do a long, in-depth mutual due diligence process with every company that we bring in. And that's dollars that help supplement the investments that are here or the match funding, et cetera. I'm super happy working at Eagle Point because I've got companies that, because we work together, they sent their stuff to space. They have stuff that went into the Air Force, NASA, almost every federal agency that I can think of, we have winners from. So my job is super interesting and I'm super happy about it. Besides that, really cool programs are open in the next 3 months. We have NASA that's closing in March. We have the National Science Foundation. The Air Force is opening their open topic on February 5th.
Anyone else lose audio?
I think you cut out there.
I think your audio cut out for a second there.
Can you hear me now?
Yep, now we can.
So basically, here at the bottom, you can take out your phone or scan the QR code or email me at yoav@eaglepointfunding.com. And I'm more than happy.
Thing to post publicly?
So, I think somebody needs to mute. But anyway, wishing us an awesome showcase. And I'm really happy seeing some of the familiar faces. And again, hope to chat with you, and I'll let the rest of the companies take the stage. But thank you.
Absolutely. Thank you so much, Yav. And one extra addition that I'd be remiss not to mention is one thing that we're adding along to some of the Eagle Point work is we're planning on opening up a deep tech marketing to help more companies out, especially in the dual use space, figure out how to get more traction and find more end users. So that's something we could talk about. If you want to talk to Yoav, would also be the gentleman to talk to if that's something that could potentially interest you going forward. All right. So the first session, we're currently in the opening presentation and introducing the panel. After that, we're going to have Spark Industries, Huang Recoilless, Volt AI, MPEC, Multiscale Systems, and AI Fly Labs. With that, I'm going to stop sharing and get to the, arguably, in my opinion, the more interesting part of the introduction session. And I'd like to introduce the panel and have, the panel speak a little bit about what they're looking for or who they are. And with that, we'll get started. Let's start with Todd. You want to go first?
Yeah, sure. Thanks, Asher. Todd Coulard. I'm a retired Master Chief from the Navy. My background is primarily in special operations. I'm with a firm called Mark Ventures. We're in our second fund right now, focusing on emerging defense technology, looking at Series A and Seed. Happy to be here and excited to hear what you guys have.
Happy to have you. Thanks for joining us, Todd. Next up, we have Noah Feingold.
Hey everyone, I'm over at Stellar Ventures. We are a space and defense focused fund, primarily in pre-seed and seed. You can find out more about us in our portfolio at svc.vc. Great to be here. Great to see so many familiar faces.
Perfect. Happy to see you as well. Darren Burrell.
Good afternoon, everybody. Darren Burrell. I'm the founder and managing partner of Veteran Ventures Capital. We're on our second fund, and we invest at the intersection of dual-use technologies and veteran leadership, typically in the Series A arena. And super happy to be on another one of these. Look forward to hearing the great pitches and some good innovation coming out from the community.
Awesome. Happy that you're here. All right, Craig Lewis, you're up.
Hi, everyone. I'm Craig Lewis. I'm with Eaton Corporation. I'm in our industrial sector strategy and business development group. So we have sort of broad M&A investment and strategic cover for our mobile end markets, which includes aerospace, e-mobility, and vehicle. So really happy to be here today and looking forward to seeing the pitches.
Awesome. Happy to have you. Craig McClellan.
Hi, Asher. Thanks. Nice to be back here. Calling in from up here in Canada, and only comment I'll make on what's going on is I've been watching very closely all of the news coming up across the border over the last week or so with everything going on. So exciting times for sure. So yeah, I'm with a federal government agency up here in Canada that focuses really on mostly supporting industry innovation and helping companies grow in Canada. But we also work with our defense sector and help connect whether it's academia, industry, other associations and the like here in Canada with stakeholders around the world, whether that's prime contractors or interesting startups like we'll be hearing from today, or earlier staged companies, and really trying to help make connections between Canada and the rest of the world on some of this really interesting defense technology. There's also funding and other, foreign direct investment opportunities I'd be happy to talk about if anyone wants to know more about coming up to Canada.
Sure, absolutely. Happy to have you. Next up, we've got Gus Domel.
Hey everybody, quick intro on myself. I'm sorry, I'm just kind of jumping in now. I'm from a very technical background, did a PhD and all that jazz, and directed product at a startup for some time before switching over to VC. I'm a principal at Boost VC. We are investing now out of our fourth fund, and we love early stage deep tech across the board, including a lot of the stuff that we'll be seeing today. So that's a quick summary on myself and Boost.
Absolutely. Happy to have you. Thanks for joining us. All right, next up, Lee Silvestri.
Yeah, thank you. I'm very happy. I'm sorry. As I come off mute, very happy to be here. And my background is primarily technical ops research, engineering, mathematics. And I got involved at the intersection of technology and DoD technology and national security early on. Lots of years in the field, starting a small company in light and color, as well as working for a prime Raytheon Systems, as well as working for now the private sector. So my role is with Naval X. The Naval X ecosystem is so that the Navy can get at technologies that they don't have to reinvent and they don't have to invest in, and they can help companies through roles like mine pivot or look at dual use applications for what they're doing. So I sit out in the community and represent the East Coast US. I'm considered the Northeast Tech Bridge Coordinator. I have counterparts in the tech bridges up and down the East Coast, and we have quite a burgeoning partnership under the AUKUS and Canadian umbrella with a North Atlantic Ocean Alliance that we're forming around responsible and productive use of our shared ocean space. So very happy to be here. Thank you.
Hey, thank you for joining us. Happy to have you. Miguel Vasquez, if he's here.
I am
Sure.
here. Can you hear me,
Perfect.
Asher?
Yeah,
Hi,
I can see you now.
Miguel Vasquez. I recently transitioned to venture capital. I'm based in Las Vegas. So I work with two firms. The first is VU Partners and its academic arm, VU University. So VU Partners is a multi-stage global geek tech fund. We focus on 5 verticals, and we have offices in San Francisco, Sao Paulo, Munich, and Shanghai. VU University is our venture capital investor accelerator. Under the corporate umbrella, we also have real estate private equity, and which is also an investment accelerator, fund administrator, LP matcher, and a syndicate. I'm also part of the Las Vegas startup ecosystem. We have several programs, including an accelerator, angel investing, education programs, dedicated funds, and syndicates. So thank you again for the invitation.
Thank you for joining us. Thank you for joining us. Next up, we have Paul Garcia.
Good morning, Paul Garcia. I'm a senior advisor of business development for the Air Force Office of Energy Assurance, a contract with Booz Allen. Our office in the Air Force works on installation energy. That's anything power, water that is utility connected. And we have 200 bases around the world that we support.
Awesome. Thank you for joining us. Next up, we have Katie Vasquez.
Hi, I'm Katie. I'm an investor at Calibrate Ventures. My background's originally in astrophysics, but Calibrate is an early stage deep tech focused fund based here in LA. So we typically invest pre-seed to seed across all the different umbrella areas that deep tech touches.
Awesome. Thank you for joining us. Next up, we have Katie Weiss.
Hi, everyone. I'm Katie Weiss, principal at FF Venture Capital. I have 7 years of venture experience and 7 years of not venture experience behind me. And FF Venture Capital, ffvc.com, early stage fund. Lots of historic investments in drones, robotics, and other technologies. But right now, we're primarily interested in deep tech in the manufacturing and energy spaces.
Awesome. Thank you for joining us. Next up, Rudy Desa.
Hey everyone, I'm based out of Edwards Air Force Base, focused mostly on aircraft maintenance, but we're always interested in what's out there for innovation, which it touches pretty much things like AI, ML, all the way down to advanced manufacturing. So looking forward to hear what's out there. Thanks.
Awesome. Thank you for joining us. And that's the lineup for now. Some folks might join in between, so I might do a couple more introductions in between as we go along. So be on the lookout for those. Now we're going to get started with our main programming. Without further ado, Spark Industries, if you are ready to start sharing your screen, feel free. You should be able to.
All right, trying to share. Give me a thumbs up if it's coming through and you can hear me. Awesome.
Yep.
All right, go ahead and get started. So good morning or afternoon, depending where you are. I'm Dathan Salgado, founder and inventor, founder of Spark Industries, inventor of Trident Energy Systems.
And today, I'm going to share with you my passion, which is fuel and going fast. We'll talk today about the Athena jet engine and its derivative, the Ares engine, specifically. So a long time ago, beginning of my career, I got stranded in Kyrgyzstan. The Russian government worked with the Kyrgyzstan government to pay them not to sell us fuel. So we got stranded there for several weeks. Well, the State Department worked that out. I realized that there was a big vulnerability with fuel. And to address that vulnerability, I started putting my engineering hat on. I was a aeronautical engineering graduate from Air Force Academy, and so I took it upon myself to solve that problem. Fast forward down the line, we invented Trident Fuel and Trident Energy Systems, which is a family of systems that contains the Athena jet engine. Today, one of the biggest problems that we have in the military is addressing the Pacific problem. And the Pacific problem is primarily a logistics one, right? Big distances mean you have to transport fuel and energy very long distances. And aircraft and vehicles need a long logistics chain to be able to support and operate over those long distances, including munitions. We're trying to solve that problem. So Trident Energy Systems, with our fuel, we can produce it from air and water, operate for between 2 and 10 years, unsupported, and with a modular palletized fuel production system. And with that fuel, we can do some pretty amazing things. So the Athena jet engine is the all-altitude tri-mode hybrid electric non-turbine aviation engine, and its derivative, the all-altitude reusable rocket engine, single-stage to orbit. And the main difference is that one has a fuel mix that includes an oxidizer for low oxygen or space environments. The other doesn't. Otherwise, it's fairly similar core technology. So why is it important? We got asked by the SecDef's office to do some engineering comparisons last year. And what we came up with was, it turns out an F-15, if we did a max range mission, can get out to about 2,400 nautical miles with standard fuel and engines. With our engine, we can push that out to 13,900 miles, meaning an F-15 could all of a sudden, with our engines and fuels, go out, nearly circumnavigate the entire globe. And let me explain why our fuel is so groundbreaking. So traditional jet engine stores energy in just one way, in chemical bonds. And the problem with that is, when you increase the amount of energy that you have on your aircraft or your vehicle, that means you got to increase weight. The only way to add more energy is add more weight with your high density bonds. Our fuel doesn't. We store energy in 3 ways. So thermal, electrical, and chemical, with a high expansion ratio that allows us to do a lot more things more efficiently when we're talking about propulsion or energy. All right, so why is it better? So normal jet engine intakes air, compresses it, mixes it with a air fuel mixture, combusts that fuel, and then extracts energy from that burned air fuel mixture to run the compressor. And then what's ever left over, you get used for thrust or lost as heat. With about 30% of your total starting fuel energy being used to run your compressor, about 30% lost as heat, and about 10% lost due to incomplete combustion, there's very little energy that's actually left over and becomes useful thrust. Since the jet engine was first invented in 1930, the only real advances that we've made in jet engine technology has been in the material science, allowing us to burn that fuel hotter and run better materials in our turbines and our nozzles. So as long as you mechanically extract energy from your exhaust the way that traditional jet cycles does, the best you can do is about 40% less efficient than the Athena jet engine. The Athena jet engine cycle is radically different, using fuel to cool the nozzle and run the compressor, similar to how a rocket engine's fuel turbo pumps work. Once the Trident fuel air mixture is detonated, it exits directly as thrust. So you get higher velocities, and you use what would otherwise be lost energy in the heat of your exhaust to run your compressor. So that leaves you with about 40% efficiency advantage right off the bat. There's just physics that create a gap there that no other traditional jet cycle will be able to match, even if you had perfect combustion. Now, when you combine that with nitrous oxide as a oxidizer, which is non-cryogenic, it actually, the difference becomes really apparent. So compared to the Falcon 9 Merlin 1D engine, which is a two-stage engine, our single-stage engine would save you over 300,000 pounds in oxidizer and fuel weight to get up into space. Now, what that means is you need less thrust or you carry bigger payloads. And it starts making rocket science a lot easier. If you look at the fuel efficiency measurement at sea level, 283 seconds versus the 4,925 seconds, using the oxygen in the atmosphere as your oxidizer for your fuel, very low at low altitudes when oxygen is abundant, makes the most sense. So why is our engine better than anything else out there? Well, it operates in 3 modes. So we can do a fully electric mode for low thrust operations, taxi, cruise, those type of things. Or when you want to go stealth, right? Because you're going to have basically no thermal signature, which is huge, especially when you're trying to create the collaborative combat aircraft or NGAD supporting systems, right? Whether that's drones or primary aircraft that want to maintain stealth. There's no other propulsion system that gives you, that even envisioned or proposed to our knowledge, that gives you the opportunity to actually have stealth in IR, in the thermal range. Everything else is simply in RF, the radio frequency or radar range. Then we can operate in our RD fanjet mode, give you quite a bit of capability and lower the thrust specific fuel consumption down to 0.33, and that's unheard of in jet engines. And then finally, you get ramjet or scramjet mode. So that allows us to go at very high velocities. And because we're using rotating detonation and an aerospike nozzle that gives you a vastly increased altitude and airspeed range where you maintain efficiency. One of the other key things to note is that because we have no high temperature turbine, your maintenance requirements are going to go down drastically. And you can see one of the things we're looking at for our next steps, we have several phase 2s that we're looking to start work on this year, actually in just a couple months, in conjunction with our FAA Part 33 engine certification program. And what we're targeting is TBO or maintenance intervals that vastly just kind of put everything else to shame in the market, doubling or potentially even tripling maintenance intervals. And that is the real cost savings that you get over the life of an engine. You can see what the comparison is. We're projecting an operating cost of $300 to $400 per hour ish versus the $600 to $800 per hour that you get with the same size engine for this first engine that we're going to do, which is a small scale, small jet or munitions scale jet engine.
30-second warning.
Yep. So what are we looking for? Anybody out there in the government that can help us sign our customer support memos for our 2 efforts next month. And then also looking for interest, accumulate the early orders for our engine certification. We want to drive down that fixed cost, that per engine cost by getting as many out there. Our target is going to be an initial order of at least 400, but happy to take more and scale our target manufacturing 3 years down the line to deliver on whatever that is. So that's what we're looking to do. We're working with Air Force, AFWorks, AFRL, Headquarters Air Force. There used to be A57 Logistics Under Attack Team. They're transitioning to a whole other unit, much more broadly focused to the entire Air Force. And then several partnerships with the Air Force Academy. So happy to take any questions.
Awesome. Yeah. So how it works is if you can raise your hand on the Zoom like Gus did just now, we'll try to go in order. If you can't figure out where the button is, it's under reactions. If you can't figure that out, also feel free to pipe in. Gus, go right ahead.
Yeah, thanks for the presentation. I really appreciate it. Just one kind of thing that I was curious about is the long term here. So like the long term vision and goals. Like if this goes well in 10 years, like what does this look like to you in your mind?
So this small scale is going to be kind of the first iteration. So it's going to be munition sized small jet aircraft. We want to get to the big aircraft also, and then also transition that into what we learned there to be able to make rocket engines. We think that getting it up into orbit and then having to refill 20, 30 times to get to, say, the moon or Mars makes those really kind of questionable decisions. But we think with our jet engine, the higher efficiency, that's going to make that a lot more attainable and cost effective. And that's going to be huge. So on the big picture, that's kind of the long-term goal. The other thing is our fuel production systems, and then bringing that also to the commercial. So our fuel production systems and ground vehicle transition. So there's a lot I haven't talked about that we're doing for ground vehicles, fuel cell electric vehicles, and combustion vehicles, that we can run our fuel both in combustion mode and in fuel cell electric direct mode.
Gotcha. Great. Thank you.
All right, Todd and then Lee.
Yeah, Dathan, I had the pleasure of talking to you previous to this day. And I'm a huge fan already, and this is even more ammunition to get excited. But just to let you know, I am following through. I know you don't primarily talk Navy, but I am following through trying to get the right folks in the Navy, namely Naval X and the folks at Nav Air, focused on this, vouching for the technology, asking them to look into it seriously, particularly for our at-sea carriers and some of the naval aviation that we do. So stay tuned.
Thank you, Lee. I really appreciate it.
Todd, you're up.
Yeah, this is awesome. Super, super cool. Can you talk about your raise? Are you currently raising, or do you have a plan to raise? And then where is the patent on this?
Great question. Actually, we do have we're building that plan right now. Yes. So I have later this week our funding plan meeting. So yeah, we're doing that. If you want to be part of that, yes, Sean McDevitt, he's our guy. Happy to get you in touch with him. He's West Point grad, fantastic guy. Got 20 years of experience with Goldman Sachs and all that stuff. So he can talk a lot more smartly on that front than I can. But yes, if you're interested in that, anybody's interested in that, the perfect timing.
Cool. And I'll definitely send you a message after this, but is there any patentable technology on the fuel specifically, or the engine, or where does that lie?
Yeah, so the fuel, yeah, we're preparing additional patents for the engine. There's a few more tweaks we want to do on the engineering side before we do that. We already have filed patents on the fuel and the fuel production system. So the baseline, really no one else can do what we do without the fuel, especially in the jet engine space. Traditional fuels and really no other fuels out there either have the density, like hydrogen just isn't dense enough on its own, or the expansion ratio. Normal fuels is like at 200, we can get up to 1700 to 1. So massive gap in ability. So you just can't run our engine without the innovations from our fuel. Yes, and that is a patent that we already filed.
Perfect. Craig, last question.
Yeah. Hey, thanks for the presentation. I guess just about the fuels, is that compatible with existing fuel systems with, on an aircraft?
It can be, yes. Typically you got to modify the fuel lines and stuff like that. The one drawback with our fuel is that requires stainless steel fittings. It's corrosive with brass and silver and stuff like that. So as long as it's stainless steel fittings, you're good. Traditional infrastructure for propane, as long as you change the fittings to stainless steel, works with our fuel perfectly. So yes and no, right? There's some engineering that goes into it, but yes, it can. It's not necessarily an efficiency boost, but if you just want to preserve and use your infrastructure in the interim, yes, that's possible.
Got it. Okay, thank you.
Perfect. Awesome. Thank you so much, Nathan. Feel free to leave your contact information in the chat so folks can contact you, and thank you for the presentation.
Will do. Thank you.
Awesome. Next up, we got Song presenting Quang Recoilless.
Okay. Can you guys hear me? How come I cannot share sound?
We can hear you. Oh, I think it's a setting on my end that I need to fix. Give me 1 second. For now, give it a start, and then I might ask you to reshare. Song, feel free to start whenever you're ready.
Okay, great. Let me. Okay. Hello. This is Song. I'm fond of Huang Liquids. I came from a chemical physics background, so and I cannot claim to be an expert in firearms. And
just to
can
jump
you guys
in,
hear me? Sorry?
we can hear you. Yeah, just can you switch the displays?
Okay, sorry.
Yeah,
maybe.
all good.
Sorry about that problem. Maybe it's because my display setting. Let me do
Yeah,
it.
it's just in the PowerPoint because we're seeing presenter view.
Okay. Is it better now, or you guys see my screen?
I see the whole PowerPoint. If you want to do share and then swap the screens, I think that's the easiest way. Yeah, if you want to do from the beginning.
Yeah.
Here, it's not loaded yet for me.
Sorry.
No, you're good.
I should put it. Should I do something here, or you take care of it?
No, if you want to do, just click play from beginning or present slideshow, and then switch the view.
So I can start?
Yeah, go for it. Yeah,
Okay,
if you
good.
want to just switch the view here, if you go to display settings, you can switch the view. I don't know if I'm being too pedantic.
Should I go on?
On the top bar, right next to show taskbar, there's a display settings. You see what I'm talking about? Next to end slideshow. That could also work probably. On the top, no, on the top bar on this page. Whatever. Yeah, we could go ahead. It's up to you.
Okay, let me quickly try. I'm sorry. Okay, let me quickly try again. Approve. You have control now?
Yeah. It should work.
Sorry.
No, it's not letting me do it. That's fine. But just go ahead.
Okay. My name is Song. And I was not a firearm expert, so I think the only reason I got into it is because there is it just happens that I think I can bring some outsider's perspective into quite a long-standing firearm industry. That some of the ideas that is out of box for them is in the box for me. So it just happens that I think there is an idea that the firearm industry should look into, and that's why I get into. So I cannot convince people that from my track record or something, but I just want to show want people to judge the merit by just looking at the things that we make. So basically, we are firearm innovators and developing automatic recoilless rifles. And this is for small unmanned systems. The picture is an example of what we do. Let's see whether I can. Can you move to the next slide?
I don't have control anymore. You can do it from your end.
Okay. So the problem we are solving is recoil-induced instabilities, and this video is an example of that. So you can see how the drone is kicked around by recoil, and this causes problems because it destroys the firearm and it reduces precision. That in turn reduces the operation efficiency of unmanned systems. That's because a long time for aim recovery is not consistent with the need to engage a fast-moving target. And that's exactly the limitation we have on some of the existing counter-UAS systems.
Song, I think you need to, here, I'm going to share the slideshow from my side, if it's okay with you, because I think it's not moving forward.
I shouldn't have done this extended screen thing.
Yeah, I think that's the downfall.
Did I?
That's okay. Give me 1 second. Just need to open it. Bear with me, everyone.
Sorry about that.
Brian, unless you want to share it on your end, because it's taking me a second to pull up.
Or should I kill my extended screen and restart?
Yeah, I could do it on my end. It's fine. It's opening now. Okay, perfect. I have it. Sorry about that, everyone. And I could share sound. So that's good. All right, we were on slide 2, right?
Yeah.
Perfect.
Okay. So I think I got this. So basically, let me just quickly. So the problem we are solving is recoil-induced instabilities, and see if I can move on. Can you move to the next slide?
Yep.
And our solution is automatic recoilless rifle that brings an incredible level of stability, precision, and firepower to unmanned systems. For example, you just see the in the case of in the air, you can get the stable cone of fire. Okay. The next video. And on the amount of precision firepower you can get from a recoilless rifle is just insane. It's just you seen in the video. Next slide. Okay. So the benefit of recoilless unmanned system is obviously stability. You just seen it, and increase precision firepower. And also, it will increase the combat efficiencies in multiple combat scenarios, such as counter UAS and swarms and other cases. Next slide. Okay. So our core technology it's an oscillating central bridge block technology that we invented. This is how it works. So on the bottom right picture, you see a photograph of a typical existing recoilless rifle that's based on Davis gun design. So it works on the principle that you launch a projectile in one direction, and then you launch a compensating mass in the opposite direction, so the recoil cancel. Our weapon work on the same recoilless principle, but the difference is that the conventional recoilless rifle is manually operated. So, for example, you put it on a drone, and you can only get one shot per mission, because the drone had to come back to be reloaded. Ours is fully automatic, so you can basically empty the ammo in the magazine during your mission. And in essence, what we achieve is that we figure out a way to integrate Maxim's idea into a Davis gun design, and such that the recoilless rifle have all the operating characteristic of a machine gun, and it's also very fieldable, and that's positive. Next slide. Okay. The use case of a recoilless rifle is many. It can be applied to multiple platforms, for example, UAV, UGVs, and robot dogs. And it is anticipated to increase combat efficiencies in multiple combat scenarios, such as counter UAS, urban warfare, special force operations using these capable platforms. Next slide. So a little bit about our story. We basically founded the company on the technology that we invented. We have patents, protection for our invention. And now we have a prototype that we are going to be demoing in DoD sponsor events, and we are asking help to approach end users or platform suppliers to test our prototype. So in the middle picture, it's a picture of the garage where all the trouble started, and the two rebels causing all the trouble. So, and the one on the left, the guy on the left, he looks a lot younger than me now, and it's only 2 years ago. So anyway, that's the way it is. Next slide. So we want to partner with military and government basically to have them evaluate this particular technology and capability. We are in the process of doing that. For solution suppliers, we are open, we are flexible, and we are creative. So JDP licensing, we can talk. If you have a drone and a turret, we can talk counter UAS, urban warfare, special force operations, etc. And we are also seeking investment, basically to turn the prototype into a commercial product. So drop me a note, but I'd love to talk to you guys. Thank you.
Awesome. Thank you so much. So I'm going to stop sharing so I can see who's raising their hands. We'll open the floor up for questions. Sure, Lee, go right ahead.
Yeah, a great presentation, and I certainly understand and appreciate the impact of recoil and the ability to have precision fire. What I don't understand quite yet, and I apologize if I didn't listen carefully enough, is the link in the lack of recoil to having an inexpensive, powerful ammunition. I don't see how it affects the ammunition utilized in the platform.
Okay. Can you get to the slide where it shows the traditional, no, the other one, the one shows how you, yeah, the one, okay, I'm sorry. The next one? Yeah, this one, okay. No, okay. Go back to the one that shows the, no, okay. Shows the compare, yeah, this one.
Okay.
No. Yeah, okay, that's fine. Actually, okay, so yeah, I'm sorry about that. So actually what happened is that the conventional recoilless rifle the ammunition is very special. It basically is designed to use ammunition where the propellant goes in one direction and the projectile go into another direction. It's a single piece ammunition. Okay, and our innovation is that we will, instead of doing that, we will put we will divide that tube into two. So you will use regular ammo to launch the projectile. For example, in this case, this is a regular machine gun ammunition. And then you will use a second ammunition to launch the compensating mass. And in this case, is a blank ammunition. So the ammunition we use composed of first a regular machine gun ammunition for launching the projectile, and then a custom-made blank ammunition to launch the compensating mass. And those can be very cheaply made.
Well, thank you.
Awesome. All right. Thank you. Thank you so much, Song. Feel free to leave your contact information in the chat. And thank you for the presentation.
Thank you.
Next up, we have Volt AI. Feel free to start sharing whenever you're ready. Brian, are the folks at Volt ready, or should we move forward and come back?
Here, can you guys hear me?
Oh, okay, perfect. We can hear you now.
Yeah, I'm trying to find the, okay, there you go. Share, let's see if that works. Can you guys see my screen?
Yep.
Awesome. Well, thank you so much, everybody, for taking the time in this afternoon to listen to all our discussions. My name is Dimitri. I'm co-founder for Volt AI. We're an AI physical security company that spans across a wide set of industries. But essentially, there you go. Our mission is to really reinvent how the future of sort of physical security and safety looks like across various different markets by introducing AI to be a more proactive, more capable for everyday security practitioners and law enforcement and in the military hands as well. So the problem, well, in today's traditional security, the challenges are the coverage of surveillance cameras and sort of security equipment is very limited. There's not enough humans to actually look at all the video feeds that are coming from the security cameras. There's a lot of human error and fatigue that happens during the review and the sort of operation of the security equipment. And not to mention that the high cost, both from installing all of the cameras, but also manning them and being able to respond when incidents occur. And what actually happens in real life is that most incidents are actually missed until someone reports of something happening, and then the surveillance equipment is essentially used as investigative tools rather than proactive tools to go and respond and deal with the situation. What is Volt AI? So we're a kind of a next generation security system that seamlessly integrates with existing set of hardware, security hardware that you already have invested in, particular cameras, access controls, and things like that. And what we do is we pull in the video feeds across all the cameras. We turn the video data into perception data that computers can understand, and we fuse that data together to get a better understanding of your entire environment, be it a single building, or be it a full campus, or a sort of a distributed set of buildings and sites. And that allows us to reason about what is happening in the environment, identify risks, and track those risks in real time. So if somebody pulled out a weapon in a parking lot, they move through campus without, after putting the weapon away, we can still understand that that's the same person that is armed, that needs to be monitored and responded to, and the security personnel or law enforcement can respond to where the individual is on campus rather than where he was seen with the weapon. As part of our tracking capabilities, all our AI is human validated. So we have our own security operations centers that validates all AI decisions so that if an AI thinks that there is a medical emergency or any kind of other risk introduced into the environment, the human actually verifies that the AI is making a correct judgment call before it is escalated to the end user, be sort of the security operations people on the ground or law enforcement directly. So the AI is able to do various types of risk analysis from various weapon detection, both firearms, but as well as bladed weapons, identifying physical altercations and sort of bullying incidents, finding medical emergency, various health incidents, hit and runs. I mean, you kind of can name it. It's security breaches, but any kind of anomalies that would not typically happen in a given environment. As I've already mentioned, all our incidents are identified and validated by a human being, so there's no noise that comes from our system to security professionals, which ensures that anytime an incident is being generated by our system, it is a real thing that needs to be responded to. We've built a proprietary algorithm to actually do the tracking, so we don't rely on the facial recognition. We take into account a lot of visual sort of features of an individual, as well as temporal features of how people are walking, sort of the gait analysis. And we create a fingerprint for individuals across the cameras. And no matter what cameras you have, that individual can be tracked across many of these cameras, all in real time. So we don't actually identify that sort of a person as to a given identity. We fingerprint them, so to speak, and track them without the need to sort of invade privacy and other type of regulatory restrictions. Lastly, to mention is that we enable the security practitioners to do historical investigations of what happened much faster. Utilizing sort of the Gen AI capabilities, you can interact with your security infrastructure now with normal sort of natural language. You can say, hey, show me where the white cars are. Now narrow it down by only parking garages. Now narrow it down where people interact with these cars. And that really quickly gets you to exactly pinpoints exact locations and the cameras and the time that you need to basically investigate. And then from that point on, you can say, create an incident, add these frames to the incident and so on and so forth, without spending hours and hours to find where the incident occurred, right? So it kind of supercharges your existing personnel on the ground to a degree that has never been possible before. As I've already mentioned, all of this runs on top of existing hardware. So we are actually a software company. We don't build any hardware at all. We pull in the video data, run it through AI, and the rest of the system is essentially just a web portal that people can log in from anywhere and access both their video footage as well as interact with the latest AI capabilities on the platform. The team is myself, my co-founder. We are sort of our previous backgrounds were we worked in Silicon Valley. I worked also sort of as a DoD contractor at Booz Allen Hamilton before, but my background is software engineering. My co-founder is an operations guy with military background, and then we have a team of 20-30 people who helped us build the product. What we're looking for is additional customers. So we, as I've mentioned before, we span across various industries from education to corporate to gas and oil pipelines, but we have not worked with the government directly yet. And this is our sort of initial conversations with some of the government agencies to see if there's interest to apply this type of a technology to protect both government offices, but also government installations in the military side. So any reach outs, suggestions, comments are welcome. That'll be it.
Perfect. Thank you so much, Dimitri. And as the slide chat says, got a question, go for it. Whoever wants to start us off.
Yeah, Asher, one quick question from me.
Sure.
How do you guys view your competition in the space?
Yeah, I mean, most of our competition is what I would call a smart camera. Some of the competition is like focused on like the weapon detection or some other type of detection. And true, in reality, detecting something, that's not the hard part, because most of the time, whenever you detect, that is not enough information for a first responder or law enforcement to respond to, because nobody's going to stand there waiting in front of the camera to be responded to, right? So the threats usually move, and unless you are able to track those threats in real time, your response is going to be limited, because you won't be able to actually respond to the right place in the right time. And we, as far as I know, we're the only company in this space in the industry that is able to do real-time tracking to the extent that we're doing.
Awesome. Miguel, you want to ask your question?
Sure, thank you. Thank you for sharing your vision. I just had a quick question. So you mentioned you wanted to talk to a couple different industries, right? You haven't spoken to government yet, but education, et cetera. So have you given any thought to your revenue model, like how much you're going to charge for this? Because I think some industries will look at this as an additional expense. They're trying to get a handle of that, what that is in the current environment.
Yeah, just to clarify, when I mentioned that we are already deployed across many different industries, we're just starting to work with the government or having conversations with the government. In terms of how the business model is, essentially we charge per camera stream, because that's sort of the unit of economics that we need to process. And it starts out, so we have different tiers, because we also support education environment, and that's sort of my personal passion of improving kid safety. So on a corporate side, it's a $65 per camera per month type of a charge. And then for K through 12, it's 32, so almost sort of like cost to us. And there's also economy of scale. So the more cameras customers on board, the cheaper it goes over the time of the contract.
Great, thank you very much.
Darren?
Great presentation, Dimitri. Just a quick question on your traction. What is your revenue like in your trailing 12, and what do you plan on doing, not including the governmental business, in 2025?
We're probably going to be closer to about $4 million in revenue by end of 2025. That's sort of our target.
Thanks.
Perfect. Awesome. Thank you so much, Dimitri, for the presentation. Feel free to leave your contact information in the chat so folks can get in touch with you after, of course. Next up, we have MPEC. Feel free to start sharing whenever you're ready, Herbert.
Right. I think you guys can see me.
See you, no, but hear you, yes. And
Oh,
see
okay,
the
well,
slides.
let's see the slides. All right. Well, good enough. That's good enough for me. All right.
Perfect.
So every day, 1.2 billion integrated electronic circuits get installed across the globe. This includes our nation's critical infrastructure, such as airplanes, ships, power grids, control systems, communication networks, wastewater treatment plants, and more. These critical parts include computer chips that control everything from landing gear components to nuclear power plants. Every day, 1.2 billion parts should be inspected. Teams of people tediously inspect parts and equipment and do everything they can to ensure there's not a single counterfeit part amongst them. The work they do is critical for our personal safety, national security, and our way of life. And yet, in 1 year alone, over 1 million counterfeit parts found their way into our nation's defense systems. And this is only 1 year in one division of the federal government. And the issue is even more rampant in the commercial sector, with over 25 million parts annually. United States Air Force pilot First Lieutenant Schmitz was an unfortunate victim to this massive problem when his F-16 crashed and killed him, 100% due to counterfeit parts. But why do counterfeits pass through? Because inspecting and analyzing equipment and parts takes expertise, a distributed workforce, and many times expensive laboratory facilities and research. None of these are scalable solutions. Hi, my name is Herbert Dwyer. I'm a Marine veteran and former NSA tasked operator and critical infrastructure auditor. I co-founded MPEC, a company that is purpose-built to fix this problem and others like it. Our mission is to connect the equipment you see with the information you need for faster, more effective decision-making. I've assembled the best team I could find. Here's some of my key people, to include our CTO, James Crouch, who was handpicked by Steve Jobs in 2008 to stand up Apple's App Store. He's an expert in cloud, mobile, AI, blockchain, and many other deep technologies. The rest of my team, including myself, are experts in various necessary disciplines to create a rounded minimum team. So Why do we call it data empowerment for critical infrastructure? Imagine being able to take a picture from your smartphone and get insights on accurate data on complex equipment and parts in a fraction of the time it takes using traditional methods. That's exactly what MPEC does. Our solution combines cutting-edge computer vision, applied intelligence, small vision models, and extensive data sets to transform the way we capture and analyze data of the many types of critical hardware that power our globe. Plus, we're building the world's largest equipment and part repository. We've also generated unique IP and are seeking 4 patents. And it's not just the lurking counterfeit parts in our critical infrastructure we should be concerned about. It's also the faulty logistics systems, antiquated and inefficient equipment and parts that are hidden threats. We experience these hidden threats in our drive home, flight to a conference, in our office buildings, the cars we drive, the boats we sail, and many other things that contain hardware. This is why it's a quite large market, standing at almost $30 billion across the globe with a SOM of $2.2 billion, again, annually. The core of our platform has the ability to connect images of real-world objects with the information professionals need to make critical decisions about parts and equipment. But it can also be used for logistics. For example, the Department of Air Force plans to use our technology to replace old 1950s processes like simply identifying parts for replacement or repair. Plus, in the future, those great technologies like augmented reality will need a back end to really identify what the warfighter is looking at and seeing and providing instant insights. Let's also not forget about some of the less sexy uses of our technology to include building energy audits and helping the DoD pass its first audit in many, many years. Our competition typically includes individual substitutes being stacked that lack the specialization and cohesiveness to equal the power of MPEC. Because MPEC's solution combines cutting-edge computer vision, applied intelligence, and extensive data sets to transform the way our customers capture and analyze data. MPEC's go-to-market plan is working. We've already closed paying customers and partnerships with some of the largest industrial leaders worldwide, to include the US DOE, Canada, Johnson Controls, Siemens, and others. Plus, we also have a closed contract with the Pentagon. The Department of Air Force at the Pentagon contacted us to solve the counterfeit part conundrum and awarded us a direct phase 2 contract. We're just wrapping that up actually next week. And given our D2P2 success, the DAF has expanded our contract to include a $2 million TACFI with the head of supply chain to tackle many of the integrated weapons platforms like the B-1, Minuteman III, B-52, and F-16. Finally, the warfighter can get these critical platforms back in service much faster by dumping old processes and replacing them with MPEC. Today, we're here looking for program offices that are interested in partnering, investors for MPEC's current financing round, partners for future SIBRs and SITRs, someone or maybe multiple someones for the Mentor Protege Partnership Program, and of course, commercial and government customers. Thank you very much. Happy to take any questions that you may have.
Thank you, Herbert. All right, Darren, with the fast hand.
We're good to see you again. Great presentation.
Thank you, Darren. Great to see you too.
Yeah, quick question. Can you tell me a little more on where you're at with the TACFI? Have you already raised the 2 million matching funds? Or are you in the process of doing that? Is that part of your ask? Just kind of want to hear a little bit more about that.
Yeah, great question. So we did submit the TACFI on time. The first cohort, they've released the second cohort of the current, I guess, release. So we got in on time. We have as customer the executive director for the AFTC and TPOC, the director of supply chain for the Air Force. That all went in. We have a contracting officer as part of the contract as well. We have to have the $2 million matching fund closed by obviously the time of award per the TACFI requirements. So we are raising that money right now. We were raising $4 million for 2 programs, but since we've only gone with the TACFI, which is 2, we are now at $2 million for the current raise. So we are working through that right now. So if any investors are interested in that, especially looking for a lead, we have a couple follows. But certainly we'd love to talk to you, Darren, about possibly leading or even participating in this round.
Is that a price round or is that a convertible?
The preferred route would be a price round, but we're open to suggestions. It is it's a seed round at this point, but this is enough to get us to a big Series A would be the next stage.
Got it. Thanks.
Thank you.
All right, Lee, you go right ahead.
Yeah, thanks. Great presentation. I certainly understand the applications in the Air Force and it's critical, but I also, in the world I live in, understand that with the focus on shipbuilding, sub-building, other platform building, not as critical as the sub and ship. Counterfeit and defective parts are huge, concern, huge issue. Have you approached the Navy at all?
Well, I was invited out to Naval Postgraduate School for a big gathering last week with some admirals and others that want to talk to me. Unfortunately, I had to cancel that trip due to a family emergency. But that was supposed to be our first foray into the Navy. So no, not yet. But we are very excited to speak to the Navy, especially considering I'm a U.S. Marine. It'd be great to reconnect with some of my old friends.
So if you could, maybe I can help with that, but let's stay in touch because that is a really great and effective entry point. Anything with NPS is great. This whole supply chain resiliency in the Navy, as it is in other armed forces, is huge right now, as it is in our world. So if I can help, let me do so.
Thank you. That'd be outstanding. I'd appreciate it. I'll certainly follow up with you if that's okay.
Okay, sure.
All right, Craig, you're up. I think you're on mute, Craig.
Yeah, I was. Thanks. I was just looking for the button there. My eyes aren't what they used to be, or maybe my screen shrank. I don't know, but yeah, no. Thanks for the great presentation there. I noticed the maple leaf flag there. Is that the project you did with Carleton University? Are you aware of
One
that?
of them, yeah.
Okay, you've done more. So I'm just curious what your activities have been north of the border so far.
Many. Actually, Canada is a great partner of ours. We are partnered with Natural Resources Canada. We are the front end for Red Screen, which has about 800,000 users worldwide. It's an incredible energy modeling platform, the biggest in the world, actually. So we finished phase one, we're moving to phase two. But yeah, we've done, as you mentioned, Carleton and many other universities and other campuses across Canada. I won't mention any specific customers and sites without permission from, of course, our customers that did those audits. But yeah, we are very active in Canada.
Okay, I'll probably follow up with you just directly to dig into some things and talk about what some opportunities might be. But yeah, thanks again for presenting today. This is great.
Yeah, absolutely. Thank you, Craig.
Absolutely. Thank you so much, Herbert. I'm sure you already left some of your contact info, but feel free to leave it again. I think you left it once, but feel free to leave it again.
It's in the chat.
Perfect, beautiful. So for anyone who wants, you could find it there. Appreciate the presentation. All right, and we'll
Thank
be
you,
moving
everyone.
on. Absolutely. Next up, we have Multiscale Systems. From Multiscale, I believe we have Jesse.
Check 1, 2.
Yep, we can hear you.
Okay, I'm told that Zoom's audio filters sometimes cause some interference on my end. So if you find that I'm not coming through clearly, please by all means let me know if I sound robotic or if my voice is coming in and out. Does that sound good?
Okay.
Can
Yeah.
you see this all right?
It's a little bit. There's a little bit of distortion on your end, but I don't know if there's anything you can do to change it.
You know, I've looked at the audio settings for this once or twice. Let me just try turning. Check 1, 2.
Yeah, we can hear you.
Is that better?
So. Well, I'll let you know if it gets bad.
Okay. We'll leave it on the default setting again. Okay, so Multiscale Group. Let me start with this. So the Multiscale Group is a collection of 4 companies: Multiscale Systems, Hybrid CNC Parts, Armory Technology Engineering Fund. We are internally connected, but we have different niches and expertise. Today, Jesse, I'm presenting on behalf of Multiscale, and I'll be talking a little bit about what we're doing with Hybrid CNC. But I guess it's just worth understanding that we are a vertically integrated group of nerds, essentially. And the thrust of this presentation is really about designing and manufacturing aerospace solutions for harsh operating conditions. So, multi-scale systems is really focused on engineering and design, whereas hybrid CNC is all about precision manufacturing with some advanced manufacturing techniques. I like to tell people that at Multiscale, we are building the future with the latest in advanced manufacturing technology to deliver lighter, stronger, and cost-competitive precision metal parts. On the right-hand side, you can see a photo of an example where we have a part that's being built with a hybrid process, which combines both additive and subtractive manufacturing. If this plays clearly, this is some promotional video from our CNC manufacturing group. This is what the hybrid process looks like. Essentially, what we're doing is fixturing up materials, and we are laser welding from wire to create essentially stock material that we then precision machine. In the background, you can see the spindle. It's now moved to the foreground where it's using the cutting operations to bring that part into shape. In our particular case, we are comfortable not just with additive and subtractive techniques in a single fixture, but we can feed in multiple different wire feedstocks to allow us to weave together different types of alloys. In addition, all this happens inside a 5-axis CNC, which allows us to get a very high degree of complexity. All that information is available on our CNC shop's website. If you want to see more about what they do and what their function is essentially a job shop. But from the perspective of this audience, I guess what's important and just worth highlighting here are a couple of the differentiators and competitive advantages for our technologies and process. And really, I just want to say that on the additive front, there is a lot of, let's say, scar tissue in the industry that's been built up from powder metal additive manufacturing. And I just want to distance ourselves from that and say, look, we are working with wire, not powder. We are producing fully dense components that we make in a finished state with this combined additive and subtractive technique. This allows us to offer low volume production that's flexible with no minimum quantities. And because we are vertically integrated with engineering design, we really have a team of people who are really trained to think about what hybrid manufacturing processes can achieve, which for people who have come up a more traditional manufacturing route, they tend to think in purely subtractive or purely additive or purely injection molded or purely thermoform. You take your process, take your technique. We really have this ability to create tailored components for unique requirements, even as all the way down to reverse engineering legacy parts and replacing them with our techniques. The other important point here to bring up is that we've really found a niche for ourselves, high performance materials. So this would be things like nickel super alloys, cobalt chromium alloys, high molybdenum or high chromium content alloys. And again, being able to combine multiple materials into a single structure is again another unique thing that our technology lets us accomplish. As far as applications go, we got started with all of this on SBIR funding. It started with Department of Energy, but has expanded into NASA SBIR funding as well. And the beachhead for us ended up being bearings. The bearing on the left half of the screen, that was a 1-inch diameter bearing that we made for NASA. They had some low temperature and harsh environmental conditions that we engineered for. The bearing on the right, that is about a 15-pound bearing, so significantly larger. And that was designed for applications in the nuclear energy industry, specifically going into molten sodium reactors. In both cases, we do the design work, we do the first articles, we do production, and we do inspection as well. So again, vertically integrated. Oh, hey, look at that. I got a bullet point on this. Vertical integration. Beyond that, leading edge technology, I hope I've really highlighted what the manufacturing technology really can do. And I think it's also worth stating for this audience in particular that we have several really important certifications, ISO 9001, AS9100 being important on the manufacturing and quality side. And then these last three, NIST 800, 171, and then CMMCL2, DFARS, those, depending on how you come into cybersecurity, you'll learn one, if not all three of those acronyms. And I'll just say that we are compliant with the necessary cybersecurity requirements to be operating in the spaces that we operate. So, ultimately, we are a group of nerds. We like to solve problems, and we don't like solving problems that no one actually has. We like solving real world problems. So, for the folks here who are, I would say, end users of the parts that we make, we really want to know about your toughest problems. We want to know about the challenges that you're having, and we want to propose solutions. We want to create those solutions. And for the folks here that are more financially oriented, I'll say that, on one hand, it would be great to be introduced to your portfolio companies to see if we can help them be successful. But I'll also just add that as an organization, we bootstrapped up over the last 6-7 years, thereabouts, SBIR funding, more conventional lending, and we're really in a really exciting position right now. We've tripled our production capacity. We're in the process of breaking ground to build a new manufacturing facility that'll be open in about 24 months. And we're really looking to try and hit our growth curves. So I'm happy to talk with anyone and everyone who has any question, unless it's about the meaning of life, because I can't answer that. So I'll say thank you. I'll turn off the screen share so I can see people and take any questions you have. Thank you.
I was planning about asking you about the meaning of life, but I'll let other people go first. Perfect. Can you, if no one else wants to ask, I'll ask a few questions. Can you talk about some of the use cases that you have, or things that people wouldn't think would be a use case but are use cases? I guess would be my first question.
Yeah. So there's a couple of different commercial use cases. One where as engineered systems continue to push into higher temperatures, higher loads, more corrosive chemistries, and more demanding environments, whether that be in, say, Mach 5 travel or next generation energy, the materials that are out there are difficult to work with and challenging for the existing supply chains out there to be able to supply those components. I think in a conventional job shop, if you were to go to them and say, hey, I need you to make this thing for me, many of them would no quote. And we find that the differentiator of having the engineering and designing here in-house allows us to tap into these, let's say, surprising or unexpected needs, where a domestic supplier is really a requirement for the application. We've done work with valves, we've done work for cryogenic applications, we've done work for mold tooling in general manufacturing industries, and others as well, and underseas applications too. So,
Sure, Craig, go right ahead.
Yeah, hey, thanks for the presentation, Jesse. I guess you mentioned you tripled your production capacity. I guess can you give an example of maybe like a high runner, part that you would do, number of parts per year? I guess you could just elaborate on that.
Yeah, so one of those bearings that I put on screen, that was probably like $5,000, maybe $6,000 bearing, to give you an idea.
Okay.
And we've got everyone here moving at full speed, pretty much busy all the time.
Okay, great. Thank you.
Mm-hmm.
We have time for one more question if anyone. Lee, go right ahead.
Yeah, thanks. I didn't get my hand up fast enough. So Jesse, I know you and I have talked. I cannot recall if you were able to make connection into the MEP system. Did you or?
Yeah, so Mass MEP is a known entity. We've got a number of different people there that we've engaged with and talked with over the years. They have a lot of great training programs and opportunities, and I think we're on their list of suppliers, if I recall correctly.
I hope you are. And again, if that connection didn't happen with Polaris, Rhode Island, with Massachusetts, Mass MEP, I want to make sure you're integrated into the extension partnership, because we have a lot of good, like, brains and nervous system type system developers here, but we don't have a lot of advanced manufacturing here in the East. So I want to see what I can do to help get you into those circles.
Layers, I'm not connected to at the moment, but there is, from my perspective, always a need to try and find more opportunities and more ways to introduce this technology. I think the sort of barrier that I find running into from time to time, I'm sure it's open with everyone here, is that because the processes that we use require qualification in regulated industries, there's oftentimes this sort of initial parts that need to be made and validations, and those take time and effort. And so we're glad to engage in that and happy to participate in as many trials that we're able to find and identify and to, like I say, help build the future with this technology.
Okay.
Awesome. Thank you so much, Jesse. Thank you to all the panelists. Yeah, feel free to leave your contact information. All right. I'm a broken record, guys. I apologize. Next up, we have, let me say that right, AI Fly. Feel free to start sharing whenever you're ready.
All right, sharing my screen now. Yeah, so we are AI Fly. We improve drones with our AI flight controllers, and we turn each drone into a weather station. So there are two intertwined problems that we set out to solve. 10 years ago, we were promised a future with flying delivery, flying internet, flying cars, but it's 2025, and a lot of companies have scaled back their drone divisions. There's been huge leaps and bounds when it comes to miniaturizing electronics and battery tech, but stabilization methods to fly in bad weather have remained stagnant. So currently 50% of drone flights are restricted by bad weather, and that number is only going to go up with climate change. So we can't control the weather, but we can control how our drones handle bad weather. Current AI struggles because it tackles this problem at a high level. It does things like path planning and obstacle avoidance. It's abstracted away from the low-level, low-latency controller that directly interfaces with the motors. At AI Fly, we uniquely engage turbulence at this fundamental control surface. We do this in a software flash that is plug and play with existing flight systems. Increasingly cheap compute has enabled reinforcement learning-based AI like us in a variety of fields. One recent example being DeepSeek R1. Through funding from the NSF, we've developed a proof of concept technology that can achieve a 100% increase in the performance envelope, enabling 4 times more flights than current protocols. Just as an aside to this, as part of the NSF program, we conducted hundreds of interviews with drone operators in the US military and private industry. Typical protocols say that you can't fly in winds exceeding 8 meters per second. We can extend that flight envelope up to 16 meters per second. That distribution isn't uniform. It's not 16 meters per second wind as much as 8 meters per second wind. So even though we double the envelope, we enable far more flights near that 8 meters per second threshold. So equally important as enabling flight in these adverse conditions, our tech also allows us to collect brand new weather data. So this is important because to mitigate climate change, we need to predict it. And to predict it, we need data. Current weather models rely on data from weather stations, radar, or balloons. But storms are too difficult to peer into to resolve the winds aloft with our satellites. So we get these spaghetti plots of trajectories. Wildfires, we're in California, so it's pretty close to home here. But they're hard to map due to the danger of collection. It's hard to get accurate wind data near the convective turbulence caused by those fires. But we don't really know the risk. We can't model it, so we can't price that risk. And because we can't price it, we have to spend trillions of dollars to fix things afterwards when they break. So how can we better price that risk? The solution with most AI is we need more data. Right now, the US has 180,000 weather stations, but they're stationary, they're expensive, and they can't really get the winds aloft that easily. But we already have 1 million drones that are flying around doing their own missions. So why can't we use these to augment our weather models? A unique solution that we provide is By inverting our AI flight controller, we can back calculate the winds aloft during that flight, during that mission. And that density of this extra data, can improve forecasts by 3x. So both of these problems, drone control and weather prediction, synergize together. On its own, our AI autopilot enhances itself each time it flies through reinforcement learning. And on its own, the wind data enhances itself, collecting more and more data, making better and better predictions. So the autopilot lets you go places you couldn't before, collecting data you couldn't before. And the wind data, tells you can go to these new places and collect more and more data in this self-sustaining cycle. So together, these make up the two pillars of our businesses. The first is the AI autopilot. It's entirely software-based, so it's platform agnostic, and it enhances safety and stability for a range of applications like defense and agriculture. The second pillar is improving these weather models. Resolving the wind these drones fly in offers a unique and untapped data source, which can be used for micro-weather forecasting as well as to de-risk extreme weather events. So this sets us up for two growth markets to consider. By 2030, drone services is projected to grow to 65 billion. We're focusing on target markets in uncontrolled airspace of infrastructure, agriculture, and defense. And our unique improvements for air superiority give us a sizable beachhead into those markets. The next is climate mitigation. Due to worsening climate change, it's expected to grow to 51 billion. And data analytics makes up a large single share of that at 20 billion. We offer new and untapped data sources, which are very valuable in predicting edge cases and extreme events, which is important for financial markets as well as risk mitigation. I'll start to wrap up. We are an NSF SBIR funded startup. We developed our prototype flight controller, which has been proven out in simulation. We have a small leadership team with education from Stanford, UC Santa Cruz, and the UNC Chapel Hill, with representation from companies like Apple, Los Alamos National Labs, Anduril, and the US Navy. We are pre-MVP, but we have de-risked the controller from the NSF SBIR that we've been awarded. We built drones preloaded with our controller, and we've also designed a wind tunnel. We need to do sim-to-real training to grow from this proof of concept to MVP. And we're here because we're interested in connecting with investors and partners to get the resources to turn that into reality. So yeah, my info is at the bottom. I'll put this in chat afterwards. And Anish is also here, and we can take any questions.
Absolutely. Thank you so much, Ben. All right, floor is open. Otherwise, I have one. I'll do mine while I'm waiting for some folks to get warmed up. Just in terms of use cases, just to be clear, it's both. Could this system be used at all for like land use cases, or is it mostly just for drones?
It's mostly for drones. We've proven it out for quadcopters, but we could also use the same technology for fixed wing. We've actually had some conversations with some Air Force people that were very interested in the fixed wing application side of that.
Sure.
And kind of fundamentally, you can think of this as like control and uncertainty. So I think the biggest application that isn't airborne is actually naval. So there's a group with NASA that we are talking to, and it's basically tracking buoys, which is kind of a similar type of problem. But usually, it really, if you have any sort of system where you can't write the physics down super well, and simulating it is very expensive, and you want some type of control mechanism in those environments, this technology has some kind of traction in that space.
Sure, that makes a lot of sense. That makes a lot of sense. Perfect. So I'm not gonna drag it out too long. Thank you guys so much for that presentation. And yeah, of course you already mentioned that you left your info, so appreciate it, and thank you again. With that, we're gonna move to our next presentation. We're gonna go forward with Macrove. And presenting, I believe, will be Matt. I believe.
Yes. All right, thank you. So I'm Matt Levinsky, Director of Business Development at Macrobay. For the past close to 40 years, we've been installing material handling systems for companies like Amazon, FedEx, and Walmart in their warehouses. But in the last about 3 years, we've shifted our focus on designing and building robotic systems to basically fully automate all of these material handling processes within the facilities. One of the systems that I'll show you in the next slide, actually we were awarded our phase 1 AFWERX proposal. So we are looking for stakeholders' feedback as well as any sponsors for direct to phase 2. So to kind of go over high level what our systems are, first being our mobile warehouse system, and I'll have videos of these in next slides so you can kind of see it in action. But this is basically a full warehouse that's built on top of a trailer. So it's rugged and portable, able to pull up to any job site, anywhere that it's needed. And basically this system inducts, stores, picks and kits materials that are stored in bins. So this utilizes AGVs and AMR robots to move bins within the system, and then 6-axis robot arms to pick those materials out of bins and put into final kits. All of the software that runs these systems are proprietary to us. They also utilize AI to optimize the process of where to place bins within the system, and also vision-based of what items to actually pick out of those bins. Next, use the Artemis warehouse. This is actually using that same technology that's on the mobile warehouse, but this is going to be in a fixed warehouse setting. And it can be very large, pretty much as large as needed. But to kind of give you an idea, a 10,000 square foot facility, which is actually pretty small in terms of warehouses, that can store up to 8,000 SKUs and 8,000 picks per hour, which is actually very, very high. Next, we have a mobile sorting system. This is basically built inside of a shipping container or even in the back of like a delivery truck. And robots actually go and pick bins off of racking and move towards a table to the front. So you can kind of automate the process of picking bins that are needed in a mobile setting. And then again, also we can do this in a fixed setting, much larger scale. But these robots will use swarm technology to not run into each other. Item is selected on a dashboard. The robot knows exactly what bin that item's in, and we'll go and retrieve the bin for it. Won't go over all of these line by line, but basically we went through kind of a competitive analysis of traditional hard automation, conveyor belts, sorters that you might find in Amazon facilities now with our autonomous robotic systems. As you can see from all of the green data points, using the robotics and automated systems are a lot more optimal than your traditional automation. So as far as military applications, you can kind of look over all of these, but I'll go over one that we're currently working on. So a major defense company asked us to look into fully autonomizing the drone assembly process. So they build these drones. Right now, it's kind of a lot of manual labor as far as putting the pieces together. So with our system, we're actually able to move that drone through an assembly line using 6-axis robot arms with tools, and then robots to kind of move it down an assembly line process, fully automating it pretty much up to 99%. In addition to that, we're also helping them with kind of automizing the repair portion of it. So right now, when a drone is coming back from its mission, it can actually ping to our system what parts it needs replaced. The system then will say, okay, those parts are in these bins. The robots will take those bins. The 6-axis arms will pick those items out, place it into a final bin, and then the robot will then take that to the landing strip where it would meet a tech to do all of the replacement parts. So again, just kind of fully autonomizing all this process to have less human intervention. The idea also with all of this is that we can place all of these together to kind of have a fully autonomous system in a remote airfield. So using that autonomous warehouse and those sorting trailers to basically autonomize all the processes needed. Now, as far as civilian applications, again, we have some listed here, but I'll tell you another one we're currently working on. So a global snack company was looking to automate the process of creating their variety chip boxes. So the ones you find in the grocery store that have a bunch of different flavors. Right now, again, very manual process of people taking those chips, placing them into boxes. So with our mobile warehouse and our mobile sorting, we're able to actually have robots pick and choose which chips need to go into each box and do it all manually. So this, again, removing any need for human intervention. Just to go over some of the benefits, oops, thought that was a video. So this does have enhanced flexibility and scalability. So these are not out-of-the-box systems. We work with customers to design it based off of their needs, whether that's how big the parts are, the space requirements, if it's mobile or fixed. These are designed specifically for customer needs. We also found that it does reduce capital investment, especially with those mobile applications. You don't need to buy large warehouse spaces, especially if it's a temporary job that you need. Also lowers operational costs long-term. These robots, they have a lot longer shifts than humans would. The system uptime runs quicker. The scalability of it, everything's kind of more optimized with these systems. And that's something we really try and do for our customers, is to find ways to optimize their facilities, make it fully autonomous. All right, so thank you very much. Again, right now with that AFWorks, we're kind of looking for some stakeholder feedback on industry issues, and then any direct to phase 2 sponsorships. On the civilian side of things, we're also talking with some VC companies right now, kind of pushing in a little bit more capital to grow this business. So thank you. Any questions?
Awesome. Thank you, Matt. Yeah, let's open up the floor.
I had a
Miguel, go right
question.
ahead.
I had a question. Matt, this is Neil. So you mentioned that the robots are aware of each other and they can kind of avoid collisions and all that. But what happens if a human comes into the path?
Same thing. So they all have vision-based system that can detect any obstacles within the path. So like, we're trying to kind of reduce the amount of humans in these by replacing with robots. But if there are humans needed, they definitely detect those and are able to stop.
Okay, thanks.
All right, Miguel.
Thank you, Matt. Very interesting company. I had a question, so I apologize if I missed it. So are you building robots in-house?
No, so that's another kind of benefit. We're completely robot agnostic. There's oversaturation of robots out there in the market, so we're not trying to reinvent the wheel. But what we do is we kind of go out and meet with a bunch of different robot manufacturers, find their strengths and weaknesses as it comes to our systems, so we can pick and choose what's best for the customer. So if they have like some weight capacity issues, we can choose a different robot. If there's something specific that an arm needs to do, we can choose a different manufacturer based off of that. So again, we can pick and choose based off of customer.
Yeah. Right, so if you find it cheaper, solid, okay. So then basically, I mean, have you spoken to like, because I mean, you look like you want to disrupt almost logistics, and warehousing, similar to like Prologix or even like Amazon, et cetera. I mean, there's a lot of trailers out there. If you could turn all those trailers into a warehouse, that's an interesting concept. So I mean, that's your vision, if I captured it correctly, right?
Yeah, that's a section. We're not trying to really compete with the Amazon level at this point. I mean, that's a giant. That's probably too much of a Goliath to tackle. But to your point as well about all those trailers with that snack company, we're also looking at for their delivery trucks, how we can actually pick and kit orders in the back of the vehicle while the delivery guy is in the store actually saying, okay, we need 5 packs of donuts, 5 packs of cupcakes. In the back of the delivery truck, we'll have that fixed arm actually picking that order live.
Got it. Thank you very much.
Yeah, of course.
Cool.
I had a couple of questions, Matt.
Yes.
Yeah, it's very interesting. Could you talk a little bit more about exactly what it is that you provide? Is it you say you work with other robots, so is it a vision system? How do you then catalog the different things that you're going to pick?
Yes, so we have our own, it's basically a combination of a warehouse control system, warehouse management system, and then a robotic vision system. So that's kind of the big proprietary aspect to this. We also have patents on the whole trailer-based mobile systems. But yeah, what we really bring to it is going to a customer, hearing what they need to move as far as material, and designing the system basically to be able to do that. So we do catalog all inventory that's live tracked. We utilize RFID for tracking materials within the systems. We're utilizing scale base. So when an item comes in and out of the system, it can weigh that bin to determine how many materials have been used. So the software kind of just basically allows everything to run itself without a human needing to check boxes or keep an eye out on things. So that's kind of the big proprietary portion of it.
If I could follow up on the setup part. So you mentioned RFID, but also weight. So let's just use the military as an example. The military has a huge number of very odd parts sometimes. So how do you get a catalog to make that work? Is that what the AFWorks project is about?
To an extent, yeah. And I think the AFWorks is also kind of just about the automation process of getting rid of, warfighters who are doing things like lifting bins and categorizing everything and having robots do that. But the idea being that we can just with an upload of a list of materials into our software, be able to track how that comes in and out based off of weight, RFID, and then also when certain materials are picked. So let's say you need 5 MREs packed. Once that robot picks those 5 MREs, the system already knows, all right, those are now gone, and automatically updates the material list. Does that answer your question?
Well, sort of.
Okay.
So if, again, you have a huge number of parts, there's no RFIDs.
Right.
Things from MREs to bulk materials to different sorts of nuts, bolts, washers, you name it, things for fixing vehicles, what have you. So I'm curious how do you deal with something that's a very, a wide range of things, not standardized? How do you get that into the system in the first place?
Okay, so every bin that you saw on those racks, they all kind of are categorized within the software to hold something specific. So if you have nuts, that'll be categorized in a specific bin, and the system will know, all right, this bin on this shelf, this number holds this. Same with every other. So you have multiple SKUs in different bins. You can also mix SKUs in a single bin, and then the vision system on that picking robot will be able to detect what's what. It's just a lot more accurate if you have one SKU per bin, if that helps.
So that is really the setup, is getting things into the bins in the first place.
Correct. Yeah. But that's also done via robotics. So of course you'll have to program the software of, okay, we're adding 100 bolts to the system. This is the bin that it's being added to. The robot will then actually put those from whatever box into a bin and then move it into the system. But yes, it doesn't detect, okay, I see a box of bolts and counts the 100 and then adds it in.
Couple of quick business questions, if I could. So you mentioned AFWorks, and you said you're talking to a military drone manufacturer. I assume that's not a contract yet. Do you have any contracts or other market traction at this point?
Not contracts. So this was all introduced about 6 months ago, so it's still relatively new to the market. We've been kind of developing it for the past 2 years. With the contractor, we're kind of in like a phase 2 proposal. We're actually, I think, we're expecting probably March or April to actually have a contract in place to produce one warehouse unit to be able to kind of show them how it works.
One last one for me. So what kind of funding are you looking for if you're talking to venture capital right now?
So I would probably have to put you in touch with our president for specifics. But I will say we've already kind of had 2 reach out to us based off of these calls in the past. Basically looking at, it sounds like, again, without talking for my president, just boosting a little bit more capital in so we can produce more demo units of this to be able to show off. So right now in Atlanta, we have 1 demo unit of each, which often means that people have to travel to us to see it. I think we'd like to be able to have a couple more out there so we can either sell it right off the bat or have more demo units to show off.
Okay, I would be curious what you're looking for. So
yeah, that'd be great. I'll put my information in the chat too.
Okay.
Thanks, Chris.
Absolutely. Thank you so much for that, Matt. Yeah, as you said, you're going to leave the contact info in the chat. All right, we're having a little bit of a switch up. If possible, next up we're gonna have Super Seed. Jordan, are you able to present now?
Yep, I'm ready.
Perfect. Let's do it then.
Do you have the presentation? You need me to put it up?
You can put it up just so that we don't have the next sliding to make it a little more smooth. If you need to, I can put it up on my end. Just the preferred method is on your end. While we're putting up the slide, I just want to let everyone know there's a few panelists who just joined for this session. The easiest way to so that we're not talking over each other is if you go into reactions and hit hand raise. We'll be able to answer questions in order after the presentation. So feel free to use that, and really exciting time so we can get you conversations here. And if not, you can always pipe in also. That's fine too. Just just if you wanted to a little bit more order.
Can everyone see my screen?
Yep.
So good morning, everyone. My name is Jordan Darling. I am the founder and CEO of Superseed. Superseed is a material science company that has the objective to replace conventional wood-based building materials with recycled plastics and engineering polymers to create superior products derived by ample waste mankind creates every day. The problems that we're looking to solve with our new product is tackling a unreliable supply chain that anyone that experienced purchasing lumber or building homes, building buildings, or anything associated with lumber in 2021 kind of saw the failure points and the crux of the lumber supply chain. Wood is problematic in building homes, commercial properties, barracks, whatever it may be. There's off gases that are harmful, such as formaldehydes and CCAs if it's treated lumber. Wood is hard to work with splinters, unreliable performance, and effects of moisture. And with that, wet wood is weak. So whether an application in the marine industry, you have to add substantial amount of chemicals and secondary processes to protect lumber from moisture. So that is just an unfortunate element of being a organic matter. It has dramatic effects on moisture. The other big problems are associated to plastic waste. By 2040, one key metric is there'll be over 700 million tons of plastic in the ocean, which will surpass more fish than plastic. Also, every year, around 5 billion trees are cut down in the US alone. Sorry, 5 billion acres, 5 billion trees, 5 million acres. And as I mentioned, wood, whether it's OSB or plywood, has detrimental effects from the environment with warping, rotting, and splintering. How Superseed solves it. So as I mentioned, we're a material science company. We've spent about 2 years developing a formulation that allows us to have the same weight as a wood-based product while having twice the density. So that's a combination of specific formulations and additives, leveraging recycled feedstock, systems engineering approach, developing a product that has a multiple use case and multiple applications, all within the same form factor, and leveraging proven manufacturing processes that allow us to easily scale this business. So as you can see in this picture, our product is a hollow profile design. So we developed a proprietary shape that allows us to remove half the amount of material because we're twice the density while maintaining the same mechanical properties or better than a wood-based product. The product that we launched in October of last year is called the Superseed board. So the product you see here today is a marine grade lumber replacement that is 100% waterproof while being made out of 100% recycled plastic. This product is waterproof, always square, has consistent performance, is made not with non-toxic materials. Our material is recyclable, but also our product is 100% recyclable. We offer a buyback program to our customers, and we have supply chain consistency. So we've drastically reduced the complexities of supply chain seen in lumber industry and have made it soon to be all under one roof. This is good for manufacturers, for modular homes, boats, RVs, and trailers called specialty vehicles. And then also our North Star is getting in the construction industry, where we have structural subfloors, roof sheathing, and exterior wall sheathing. Displacing wood in construction. So this kind of breaks down from a high level down to where we're targeting today, the overall markets. So we've started the big goal. It's the $67 billion total addressable market, the TAM, which is global plywood, OSB, roofing, and decking. If you pare that down to domestically, the US plywood, OSB, roofing, and decking market is right around 12 billion. And then as we get smaller and smaller, start tackling the marine grade lumber. So this is treated lumber for those specialty vehicles and wet environments. That's around $350 million. And then the market that we are playing in today is displacing marine grade lumber in boat and RV manufacturers, which is right around 150 million annually. As I mentioned, our launch market is tackling marine grade lumber. So we are the only waterproof, non-wood structural replacement to marine grade lumber today. Secondary market is expanding that into construction, which we'll talk about. We have a ICC accreditation, which is the International Code Council. It's the governing body that governs building materials and construction. We've already passed that hearing, and we have that accreditation. We just have some additional testing we have to do, and then we complete that and jump into construction. Outside of that, our processes, our materials, and our IP expands outside of sheathing, allows us to get into decking market, other non-structural things like architectural lumber for interior and exterior, concrete form boards, and other different form factors with our manufacturing process. As I mentioned, the big crutch of lumber is supply chain, so that at a high level, you can kind of see the lumber supply chain at the top, a lot of steps, a lot of areas for failure. The product has to move multiple times. That's fuel, that's time, and also all different points of failure. Today, we have raw material come into our facility. Our manufacturing process that material. We go from raw material to a product in 120 feet, and then we ship direct to our customer. As we expand this business and go into other verticals, we will leverage distribution to be able to tackle other markets. This kind of just outlines our plans for this year and beyond. Today, we have a factory that can produce around 80,000 sheets per year. And later this year, around Q2, Q3, we'll be doubling that capacity in-house to around 160,000 sheets. And then towards the end of this year, we'll be opening our second manufacturing facility in the Midwest, which will be able to quadruple our manufacturing capability. The big thing with our plants is we are extremely square foot conscious. So we can produce about 1/100th of the size of the same capacity and 1/100th of the size of a lumber facility today. This is our senior leadership team. As I mentioned, I am the COO, Jordan Darling. This is the CEO and co-founder, Sean Peterson, and our other co-founder and head of engineering, Shane Kenyon. Our background is in electric vehicles manufacturing and industrial design. So we've taken what we've learned for over a decade in manufacturing, innovative and pioneering electric vehicle space, and trying to advance and bring technology improvements to the lumber industry. In summary, our product's good for builders, good for manufacturers, it's good for the environment, and it's good for our partners. We provide in-kind engineering services to our partners, whether they're OEMs, government agencies, or builders, leveraging our engineering knowledge and our experience to help build better products with our product. We can support circular economies and zero waste to landfills, which a lot of large companies and OEMs have. Those initiatives are hard to achieve when using lumber, and we can achieve that with our alternative. Our product is safe for the environment and safe for the manufacturers and the employees that use it. Thank you, and any questions?
Awesome. Thank you, Jordan. Yeah, feel free. Lee, go ahead.
Great presentation. I don't know the applications in Navy, but boy, I think this is so cool. Question, is there any considerations for unique tooling in or storage, and how does it work with coatings, please?
Great question. So yes, our tooling is very unique for the application. We designed the die in the shape of which we extrude today. Today in our factory, we have around 2 to 3 dies per machine. It takes us about 2 to 3 hours to change dies based on the application. And as far as coatings go, our product can be laminated. We actually ordered a lamination line that'll be coming so we can laminate onto the sheet. We also have the ability in our manufacturing process to co-extrude different polymers. So we can extrude a different material on the top and the bottom, different from the core. So whether that's fireproofing, whether that's anti-slip, whether that's a color or a texture, we can implement that in our line today. Our product can be painted. Our product can have other applications, glue, fiberglass, and other things can be glued onto it. Our manufacturing line has a corona treater. So we use electricity and electrode to lower the surface energy of the board. So bonding, paint, and other things can stick to it.
Thank you.
You're welcome. Thank you.
Richard, go right ahead.
Hi, great. Enjoyed the presentation as well. And Lee, I agree. It's got to be something to the applications here, obviously. So I had one question to you. Have you looked at like how it behaves when you get to storm conditions, hurricane conditions, such as debris impact and so forth?
Yes. So we actually launched our product in Tampa, Florida during the hurricane, oddly enough. So we saw firsthand very obvious need for our product in hurricane protection and storm board. So being inherently waterproof, hurricane and moisture and the effects of that is no issue. Our product is inherently UV stable, so being in the sun is no issue. We can also add additional UV cap layers. The impact strength is very, very high, being that the product is glass reinforced. That allows us to have much higher impact strength. The compression strength is as high, and in some applications higher than wood. So fastening it, whether fastener retention or putting it to a building, we have no issues with that at all.
Great, thank you.
Thank you.
Awesome. Thank you so much, Jordan, for the presentation. And I'm a broken record, but leave your contact information. I know Sean's email is on this slide, but if you want to leave your contact information in the chat, feel free.
Thank you.
Yeah, thank you for the presentation. All right, next up we have Navier, and presenting is Cameron and Evan, I believe.
Just Cameron for today. Hey,
Okay.
everybody. Let me bring up my presentation here. All right. So I'm Cameron Flannery. I'm one of the co-founders of Navier AI. We are an ML accelerated simulations company. So our mission is to redefine the engineering stack. Today's engineering world runs on software that was developed in the 60s, 70s, 80s. These old codes are incredibly brittle. They've been developed by national laboratories adding incremental features that they've needed over the years. The tools are not robust to new workflows, to the modern worlds. They're far too slow, and they aren't taking advantage of the massive amounts of computational power we have at our hands today. So we're redefining this with a GPU-centric vision to make engineering tools faster and capable of keeping up with the fast pace of engineering. We're starting with computational fluid dynamics, or CFD. This is a very mission-critical application for aerospace and defense. In the aerospace world, it's used for design of supersonic, hypersonic vehicles, for understanding complex physical phenomena before you can test. Defense uses it similarly for missile aerodynamics, for interceptors, for developing, again, vehicles that are very hard to develop physical prototypes for. And lastly, thermals is a massive application. Blue Origin's launching a lunar lander that has several heat exchangers on it itself. There's vehicles across space and aerospace that have many different types of active thermal cooling. And CFD is a very important tool in understanding the complex physical phenomena that are either hard to test for, expensive to test for, or just complex to design. So again, today's tools are really a limit on engineering. I've worked in both aerospace engineering, mechanical engineering, and in the software world. And in the software world, we have tools like VS Code and the foundations of version control, Git, that allow engineers to move at pretty remarkable speeds across large engineering organizations. Those kind of tools don't exist in the hardware world today. These tools are segmented and fragmented. So you have a design engineer creating the design in Siemens NX and then throwing the part over the wall to their analysis team. That design is then incrementally improved and understood through this iterative process that requires days, if not weeks, of iterations between design and analysis, throwing these parts and the presentations back and forth to each other. The world that we want to build is one that's much more cohesive and faster, one that gives the design engineers the tools at their disposal, the tools to make them the full team, to make them capable of doing both design and analysis in one suite. We're building an ML CFG tool, so machine learning is a really important part of what we're doing. We're approximating the solutions to these complex physical phenomenon, taking full advantage of the GPU, and allowing engineers to get instantaneous feedback on their design improvements. For example, if you're working on the design of a drone and want to understand aerodynamics, an engineer can make some modification to the drone's lift to drag ratio by changing the wing and immediately see the results. Today's world, that kind of change would require days, if not weeks, of iterations and back and forth with the different team. As a couple of examples, this is a simulation that we use as part of our training data set. On the left is the ground truth. So this is the simulation out of a high quality numerical simulator. This took a bit over an hour, which is honestly on the faster end for simulations. And that doesn't include the time it took to create the mesh and to create the pre-processing and all of the data set preparation for this. It's about 1.1 hours of simulation time. The prediction on the right-hand side is sub 1 second, significantly less than 1 second. And this is replicatable across different types of physics. So we do this for aerodynamics currently, given that that is our background and an area of interest to us. It's also a high value type of simulation that does take a long time, but we can replicate this across different domains. So this is an automotive simulation, again, ground truth on the left, prediction on the right. And we can also extend this to heat exchangers, different types of physics like materials, structural, etc. As mentioned, I'm an aerospace engineer. My co-founder is also an aerospace engineer. We have experience at some of the top aerospace and hardware companies in the world, such as SpaceX, Tesla, General Atomics, satellites at Astranis, and a few other startups here in the Bay Area. And with that, open to any questions.
Awesome. All right, Richard, go right ahead. You're muted, I think, though.
We're getting good at that. Anyways, no, I enjoyed the presentation. Thank you. I saw a number of examples, and one of the interests, I'm with the facilities commands now with the Navy. And so one of the big interests is in how structures behave in high winds. I didn't know if you have any, you showed a number of examples. Do you have any examples that you have done some analysis on various structures?
Yeah, so that's actually one of the motivations for this problem, specifically fluid structure interaction. I was working on hydrofoils for a while for a maritime company, and fluid structure interaction is a very complex simulation. Large part of that is the complexity of the fluids. So right now, we don't have a coupled fluid structure simulator. What we could do is do a simulation with ML of the fluids component and then couple that with a structural solver, traditional structural solver. So that would still see a significant increase in speed. At a certain point in the future, we are going to build an ML coupled fluid structure solver, but our focus right now is on these single physics solvers.
Okay. And at some point, I would like to get some examples on that, is share it with the people. We're moving into that area,
yeah,
or trying to apply CFD for structural testing.
Happy
to. Chris, go right ahead.
Hi, thanks for presenting. And I'm curious who you've talked to. You have quite a few impressive companies on your resumes, but who have you talked to? Has anybody used this so far? Where do you stand in terms of getting some traction in the market?
Yeah, so we've been primarily speaking to the automotive sector. We're not really sharing too much about our customers and design explorations yet, but we've been primarily focused on the aerodynamics for automotive and are now looking more at expanding into the aerospace and defense market.
Okay, if I could, just when you say you're looking at expanding, are you actively talking to people, or are you looking for connections in that market? What exactly does that mean?
We are absolutely looking for connections in that market. So this is, I guess, one of the early steps in us expanding into the market is coming to conversations like this.
Okay.
All right, we have time for one more question if someone has a last question. Otherwise, we can continue forward. All right. I'll do the last one if it's okay with you. Do you want to elaborate a little bit on You know, like in terms of some of the other use cases beyond automotive and defense, or if you don't want to go into that area, we don't have to.
I'm sorry. I
Sorry.
think I heard the
Y-
second part.
Yeah.
Go ahead.
No, I said yeah, do you want to expand on some of the other use cases you guys have as well? Or if you don't want to spend the
Yeah,
time, we don't have to necessarily.
we are really focused on aerospace and defense. You know,
Sure.
we've looked at a bunch of aerospace and automotive. We've looked at a
Sure.
few markets that are doing various types of engineering that requires physical inputs or physical constraints.
Sure.
That is really the problem that we're solving. So we are focused on aerospace and automotive at the moment, given that our solver is really designed
Sure.
for aerodynamics.
Awesome. That's really cool. All right, thank you so much, Cameron. And feel free to leave. I know that the email's up here, but if you want to leave some more info in the chat, feel free.
Will do. Thank you.
Yep, absolutely. All right, next up we have hybrid. Feel free to share your slides, Brandon, whenever you're ready.
Sounds good. Are you guys able to see it?
Yep.
Good. Okay. Thank you, everyone. Hi, I'm Brennan Liu, co-founder of Hybron. We are revolutionizing lightweight component production with a new manufacturing method for composites. Think carbon fiber. To start, our structural metal supply is in a critical situation. Aluminum is needed everywhere for aircraft, missiles, satellites, you name it. Aluminum upstream supply is dominated by China, and according to the Congressional Research Service, there's only one active aluminum smelter in all of the US that can produce aluminum of sufficient purity for military and aircraft applications. The situation for titanium is also critical, where we import 95% of our titanium sponge, with upstream supply largely dominated by Russia and China. My grandparents fled the Chinese Communist Party for their lives, and my father was a United States Air Force colonel. As an American, this situation is ridiculous, unacceptable, and a serious threat. Composites could solve this, and the aerospace and defense industry chooses composites for their lightweight, high strength, and corrosion resistance, which allows entire systems to achieve increased performance, fuel and energy savings, and decreased emissions. The problem is that producing composite components with complex geometries is very difficult. Traditional manufacturing involves placing each layer by hand, one by one. This process is difficult to scale with high costs, low throughput, and defects and inconsistencies. As a result, many complex structural components, such as compressor blades, are still made from metal. We have designed a new manufacturing process to change this, and we've just accomplished something that's never been done before, running composite compressor blades in a fighter jet engine at full power and over speed, one of the highest stress environments a material can see, and we had no structural issues. Our new manufacturing process can produce complex parts, enabling new composite applications like compressor blades, and we can do it economically. We are 10 to 100 times faster than traditional manufacturing, allowing us to be more than 5 times cheaper than machined titanium at scale. We also have 20 times better thickness consistency than traditional manufacturing. Going into our team, Aaron and I have worked in the composites industry for 10 years, previously developing the first composite pushrod that increased the performance of a racing motorcycle engine by 4%. Rahul Singh, our chief growth officer, is a U.S. Marine veteran and was a Los Angeles regional engagement principal at the Defense Innovation Unit. Craig Ellis, our principal engineer, is the former director of composites manufacturing for the B-2 stealth bomber and the former chief technology officer of Northrop Grumman. We are also being supported by a strong board of advisors, including 3-star Air Force General and former CIO of the U.S. Air Force, Bill Bender, multi-billion-dollar exited founder Jack Barron, Stanford professor and director Fukuo Chang, and distinguished UC Berkeley professor Robert O'Ritchie. Together in just 2 years, with $350K, we filed an accelerated patent application, partnered with a world-leading composite material supplier, and successfully tested our composite blades in a fighter jet engine. We have 2 more scheduled pilots where our customers will commit over $100K in testing costs and risk more than $10 million of capital equipment. Essentially, we are doing phase 1, 2, and 3 work at a phase 1 budget. Also, this technology is very broad, and we are not just a blades company. Our materials and manufacturing process can also apply to many other applications, such as munition bodies, aircraft structures, drone parts, and satellites. For our warfighters, we will enable surge production because our raw material and manufacturing is all domestic, eliminating reliance on our adversaries, and we will make composites low cost and cost competitive with metals. In addition to these manufacturing benefits, we will also be upgrading the performance of these military systems for our warfighters, with lightweight composite parts allowing systems to have greater range, payload, speed, altitude, and maneuverability. Also, lightweighting will reduce logistical constraints and GHG emissions. We've already received letters of support from Space Systems Command and from the Air Force's Autonomous Collaborative Platforms Manufacturing Lead, and are working with the Air Force's Materials and Manufacturing Directorate. We are also part of the U.S. Navy's Naval X Crucible Accelerator, being one of 2 companies selected under the category of Sustainable Infrastructure and Green Technologies. In addition, we are one of 6 companies accepted out of about 100 that applied to be in the Northrop Grumman Technology Accelerator. Currently, high-performance military systems like aircraft wings are composed of complex structures that are assembled from many different parts, like spars, ribs, and skin sections, where these separate parts take hours to days to produce, and the additional assembly steps add significant labor, cost, and time. As one example use case of our technology, which we are currently working with a large aerospace prime on, with our capability to mold complex geometries, we could mold a stiffening pattern into the skin. This would essentially combine many separate components into a single part, removing these costly assembly steps. Combined with our high speed, we could reduce the time necessary to produce assembled structures by multiple orders of magnitude, being a key enabler to the Department of Defense's affordable mass initiatives. Our ask is that for any DoD and industry stakeholders, we would love to set up follow-up meetings to delve into our technology, use cases, and opportunities. We're currently working with aerospace primes like Northrop Grumman with their technology accelerator. However, we're very open to connecting more potential industry partners, such as drone, munition, and missile producers, who would integrate our lower cost and higher performance parts into their products. I'll also add that a large part of our funding so far has been from internal research and development funds from large aerospace primes. We would love to have your support as we revolutionize lightweight component production. Thank you.
Awesome. Thank you so much, Brennan. All right, let's open up the floor for questions. Chris? I think, yeah.
Very good presentation. Thank you. And very interesting product. I wanted to ask you a couple of semi-technical questions first. So what exactly is the process? Is it a lamination type of process, or you talked about molding? What exactly are you doing in this process?
Thank you for your question. First of all, I do want to mention we actually recently met with at Alumni Ventures. So
Okay.
awesome for what you guys are doing with aerospace and defense. Regarding our technology, it is a high pressure process. So the way is instead of having like a slow lamination process, it's more of a like high speed process with basically we're getting the manufacturability of chopped fiber with the high strength of continuous fibers. And I'd love to go more into depth about that. We could go more in on a separate meeting, but some of our technology is also ITAR controlled. So I can't go too into depth on how we do that.
Oh,
Yeah.
no problem.
Yeah.
On the testing, how long did you do the compressor blade test? You know, how many hours? And in general, how does the product do fatigue-wise with any sort of, I guess it's not really delamination, but how does it do in terms of endurance?
Yeah, so in terms of the compressor blade test, we didn't have the funds to do like a very long cycle test because that was on the test cell, and you know, fuel is quite expensive when you're running a big engine. So those parts only ran for about an hour for at like maximum power. And we were actually limited by the engine. So if we ran at higher power, it would have destroyed the engine. And then in terms of fatigue, we haven't had the funding to do extensive fatigue testing, but I just generally say is composites have better fatigue properties, at least continuous fiber composites do, than traditional metals because they basically, as long as you stay underneath their parameters, their SN curve doesn't decrease as much. And then regarding the actual engine test, because we couldn't run the engine any faster and we couldn't just run it forever because we didn't have the money for that amount of fuel. What we did is we actually took the blade, and your typical rules of blade design is if you have a nick in your bottom third of the airfoil, you have to throw it away because it'll actually tear itself apart from centripetal loads. And if I could just show my screen again, with this blade, we actually made it weaker on purpose near the bottom third of the airfoil. And this is something you couldn't do out of metal. If you did this out of metal, it would tear itself apart from centripetal loads, and it would become a projectile.
Interesting. One last question for you on this. You talked about it being 10 to 100 times faster than traditional methods. I don't know if that's just for the compressor blades, which are pretty complex things, but what about cost-wise? Because that's also an issue with composites. How does your cost compare to, let's use your wing spar example.
So that's the answer to that is a bit more complicated. It depends on specifically what type of part. So if we're just making like flat panels, our cost might be maybe like 20%, 30% lower than traditional composites for thin panels. Making very thick parts where it's a lot of stack ups and where you might have some curves, our costs there, like the change becomes much more significant, would be more than 50% cost reduction in production. But then when you're making an assembled structure where you have many separate parts and we're combining them into one part, we're looking at cost reductions in basically an order of magnitude, like close to a factor of 10.
Okay.
In terms of 10 to 100 times faster, let me just add onto that. That's like our slowest process is our 10 to 15 minute molding cycle time. And traditional composites takes hours to days to lay up a part. So that's why, so even if we're making like flat panels, we can make them much quicker than traditional composites. And when you factor in an assembled structure, it only becomes more, where you're looking at on the time side closer to like 100 times different versus a 10 times difference.
Okay. Last question, I promise. Size and scale. How big can you build something?
So in terms of how big we can build something, right now, we, as a startup, we've basically, we haven't purchased very large capital machines yet. So there's no real like limiter in terms of our technology and how big we can make a part. It's only limited by our current capital equipment. And our current capital equipment, it's a pressure limitation. So it's, think about like a 2 foot by 2 foot part. But so that means that we could also make a 4 foot by 1 foot part. But we could also, but we're also looking at getting bigger capital equipment and lowering the pressure of our process, because we've only focused on small parts so far. So we definitely expect that to increase significantly as we get bigger capital equipment and also get lower the pressure. And we're expecting probably in a year or two from now to be able to make closer to like 5 foot by 5 foot or 6 foot by 6 foot parts, because where we're seeing a lot of value and a lot of demand from our customers is making like mass producing large drone airframes with those built-in isogrid structures.
Thank you.
Perfect. Lee, go right ahead.
Yeah, I'll make this quick. Great presentation. I'm very interested in the whole composite and additive manufacturing arena. Translation into Navy is what I'm thinking. I've had way too many conversations with the large manned platforms like ships, carriers, subs. They talk metal, and their concern is in the bonding, the seams, the fusion. So I'd be interested in the properties of the bonding, seaming, fusion of the materials, and also, have you explored the many applications for the unmanned autonomous arena where there's different requirements for certifications and such?
Yes, so I'd say we're actually regarding those naval applications and bonding. One advantage of our technology is that we can actually easily mold in metal inserts. So we've actually proven that by molding in a metal sheath to the blades, and we can mold in threaded inserts or mold in different areas for bonding purposes. And because we can make complex shapes and it doesn't add to the cost in production, it makes it so you can make more complex or different ways that you can put things together for sealing purposes, for underwater, or to just prevent water from going through. In fact, underwater, like torpedo structures and those underwater unmanned systems where you might deal with high pressures, another area we could support, because by being able to make complex shapes, it could actually make it a more efficient shape to deal with the type of buckling that you're going to experience from those underwater pressures. Regarding unmanned systems, I would say most of our initial applications, not all of them, will be unmanned. And right now we're pursuing a parallel paths approach. We have a large aerospace prime who is funding a lot of the internal testing, and they're trying to build like A/B basis allowables for eventually large unmanned and manned aircraft applications. But then we're pursuing a parallel path even with them and with other companies too, where we're looking at a lot more like unmanned, sometimes one-way applications that need high quantity, where a lot less testing is necessary. So we're pursuing both of those paths at once, while like that's going to be the quicker route to mass production revenue, while the other one will take more time to eventually get our parts qualified for those manned applications. And I'd add one more thing for Navy applications is we also our blades themselves. One reason we actually were part of the Naval Crucible Accelerator is they're interested in potentially using our blades to increase the efficiency of naval gas turbines, where we could reduce fuel expenditures and potentially increase the range of ships.
Cool.
Thank you.
Awesome. Thank you so much, Brennan. Feel free to leave your contact information in the chat. I'm sure some folks will want to be speaking with you further. There are some good questions there. And then, so last presentation of the day is Star Harbor. Star Harbor, feel free to get going whenever you're ready.
Awesome. Thank you. All right. Are you able to see my screen okay?
Yep.
Awesome. Good afternoon. My name is Shubham Garg. I am one of the co-founders of Star Harbor. I also have here with me Mariah Tanner. She's the CEO of Star Harbor. She's unfortunately sick, so she's staying off camera. All right. So at Star Harbor, we provide end-to-end brand agnostic commercial access to space for research and development. We have been revenue positive for the last 3 years. We've generated north of $5 million cumulative revenue, completed 10 plus contracts with space primes, such as some of the commercial LEO destination private space station phase 1 winners. We were working with one of the private space station in redesigning their astronaut health and medical curriculum to better suit the commercial customer that will be going, different from the NASA customer who were handpicked for the best health that they have. We've also been working with some of the space companies in designing their space stations and also conducting market research and providing technical consultation to them. So far, we have secured about 30 plus MOUs with key players in the ecosystem. Some of our notable partners are listed below, specifically U.S. Air Force Academy and the U.S. Space Force. We've been working closely with them. We've had their cadets come over and intern with us, and we hold a CRADA with Air Force Academy right now. A snapshot of our team members. We have Dennis Muhlenberg on our board. He was the former CEO of Boeing. Kenneth Swenson, former president of Walt Disney Travel. And 3 of our astronauts, astronaut Leland Melvin, he's an education advisor. He flew to the International Space Station twice. And Ron Garin, who's currently the CEO of iSpace, who spent over 6 months in space. We also have SpaceX astronaut Dr. Sai Proctor. She was on the first civilian mission with SpaceX called Inspiration 4 with Jared Isaacman, who is currently Trump's pick for NASA administrator in the current cabinet. We also have a rockstar space flight health and medical team, all the way ranging from special forces to the former chief medical officer of Johnson Space Center. Right now, the space market is expanding. There's more money flowing into it, both from the government and the private sector. And specifically, the satellite and payload market space is expected to explode. Not a good word. With technology getting smaller and smaller and space becoming a more interesting domain, more and more satellites are expected to launch. However, as the money is flowing into innovating technology and building capabilities in space, one of the aspects of the space infrastructure that's lacking is the back end, the infrastructure of development for space payloads and space satellites. As of now, NASA has been for the longest time the gatekeeper to space. Getting your payload to space takes about 3 to 5 years. That is usually longer than a PhD course or the life cycle of a startup or a small scale business. The longer timeline leads to higher cost, and historically their approval rate for the applications that come in are about 10%. There's a huge latent demand that has never gotten access to space. And for the new entrants, the high complexity of space payloads, it acts as a deterrent for them. At Star Harbor, we have a vertical called Lab to Orbit, where we work with first generation researchers and also new entrants to help them design, develop, procure, and test their hardware to provide a mission ready payload to them. So, and then forward on, we broker the launch and space R&D platform deals for them, providing mission ready customers to the flight providers such as the SpaceX and the Rocket Lab. We have received interest from 150 of the Fortune 500 companies in the Lab to Orbit pipeline in areas like life sciences, technology, energy, and products. And at Star Harbor, we've also created a strategic partnership with Accenture to provide access to space to their 9,000 clients worldwide. Looking at the competition right now, either the commercial providers have their single brand pipeline where you have to fit your payload into their requirements, or it's the NASA pipeline where you can build your customized payload, but you have to wait 3 to 5 years to get it to space. At Star Harbor, we will be putting together a warehouse with all of the equipment required for payload testing and development and integrating it together, working with researchers, taking their concepts, converting them into designs, and then procuring the hardware, assembling it, testing it through, and brokering the deal for launch. Through the process, we'll also be collecting enormous amount of data, both in material behavior processes as well as domain-specific data sets. We'll be using this data set in 3 ways to expedite the reducing of the timeline. Currently, as I said, NASA takes 3 to 5 years. We estimate we'll be able to bring that timeline down to 18 months, 18 to 24 months. And that one will be by removing the roadblock of wait times. A lot of these equipment, for instance, thermal vac testing has a 18-month backlog to get your payload tested. By removing the backlog and then using AI to optimize development and testing processes for each of these equipment, the most fastest process to get a payload through the testing sequence. Also using the data to conduct predictive analysis on identifying the performance and the vulnerabilities of payloads that are going up. And finally, creating a decision support system to reduce development timelines. So far, we have an extensive relationship in the space ecosystem, both in the US as well as international governments, US military and defense, with defense contractors, private space sectors, and education, and universities. Right now, we're looking $10 million for building this Lab to Orbit vertical, having the warehouse with all the equipment as well as the staffing. $6 million for the facility development, $1 million dedicated to digital products, and $3 million towards operating capital. We expect that by Q3 of 2025, we will start generating revenue in this vertical. I think that's all I have. Yeah. Open to questions from me and Mariah if anyone has one.
Awesome. Alex, go right ahead.
Great. Thank you so much for the presentation. It was fantastic. On that last slide, you said that you're looking for $10 million, and you also said it's asset backed. What are those assets?
These are the equipment for vibration testing, EMI, EMC. All of these equipments will be purchased with the $6 million as well as the warehouse. Oops. Yeah, all of these equipments are the assets that we will be holding.
I see. Okay, thank you very much.
Chris, go right ahead.
So you're working with a lot of different people. Which would you say are your primary customers as far as actually having a platform? Is it which of the commercial space station companies or NASA? In other words, who will you be feeding with this?
So right now we have an agreement with Northrop Grumman for their R&D platform in space, specifically Cygnus. We also have an partnership agreement, I believe, if not an MOU, with the Lunar Outpost for the LTV, Lunar Terrain Vehicle, inside of the Artemis mission. And I think there are two other companies that I can't recall at the moment.
Starlab and SpaceX.
Yes. Thanks, Maya.
Yeah.
Thank you.
Awesome. We have time for one last question. Otherwise, we can wrap it up. All right, perfect. I think that's that. Thank you so much for Shubham for everything, and yeah, thank you for leaving your contact information. I'm a fan. Thank you to all of the companies and the panelists that joined us today. It's been a really enlightening event. Feel free, if you guys would like to be connected, feel free to reach out to us. We're happy to help foster the connections. Also, the contact information is also in the slides and also in the chat. And hopefully, we're setting up an Airtable that will hopefully be ready soon so that you can look at the decks independently. So thank you again for everyone who joined. We really appreciate everyone's participation, and have a great rest of your day.
Thank you.
Thank you.
Absolutely.
Thanks, everybody.